catches them. One of these days, though, I'm gonna see to it that she catches them red-handed.
Will you hold it down? I am trying.
That's not possible. Ferb couldn't possibly pull that line in the wagon.
Yeah, that's not possible.
Is it? Well, I mean, it's an African lion.
Nah, it looks more like a Burberry lion.
Well, there's not that much of a difference.
Well, there is a difference. The two are hundreds of kilograms apart in weight.
Okay, well, Barbary lions are extinct, so let's go with an African one.
Well, if we want to maximize the odds of this being possible, let's assume it's 150 kilograms, the low end.
What about the cage?
What about it?
Well, the cage also plays a role. It's huge, about 500 to 1,000 kilograms, and these 10-year-old boys can only carry about 1 to 2,000 newtons.
But not to mention, the wagon can only withstand so much force. The wagon they use can only withstand around 650 newtons of downward force.
Alright, fine. Let's write this down.
Well, considering that Phineas and Ferb are roughly the same age, around 10 years old, let's assume they can pull anywhere from 1,162 newtons to 2,374 newtons. And then the red wagon. Well, the weight of the red wagon is around 10 to 11 kilograms. And the type of lion we said was an African lion. So we'll go around 150 kilograms to max it out of the possibility of this happening. And then we have the cage. We'll go with the lower bound, 500 kilograms, to also max out the odds of this happening. And of course, the wagon can only withstand 650 newtons of force. So we'll make sure to factor that in as well.
So we got what we got. What next?
Okay, well, we know that the total weight of the wagon is the weight of the lion plus the weight of the cage. So 150 kilograms plus 500 kilograms is 650 kilograms.
And the weight they have to pull the wagon plus 650 is around 660 kilograms in total.
Well, let's see if this works. First, so using F net equals mass times acceleration to find out the total vertical force on the wagon, 650 times 9.8, which is the mass multiplied by the gravity constant, we get 6,300.
Wagon can only handle 650 newtons. Try 6,370 newtons. So we already know that's impossible.
I guess so, but let's just for a second assume that this is a hypothetical indestructible wagon.
Assuming in physics, surely this can't go wrong.
Are we in any way accounting for friction?
Ayush, of course we are. That's why we have our trusty Internet Explorer search engine.
Are you seriously using Internet Explorer? You could use anything else, but you chose Internet Explorer? I mean, by the time you have your answer, I could count the answer with toothpicks.
Toothpicks? You realize we're trying to find the coefficient of static friction between the wagon and the grass, which happens to be between 0.3 and 0.5, right?
Well, what about units? What about kinetic friction?
This is the coefficient of friction. There are no units.
So we know that mu is equivalent to the force of friction over the normal force.
So what defines a normal force?
Well, the normal force is the force exerted perpendicular to the surface, and it happens to be the same as the force of gravity on the items.
Okay, so if we count for all the forces, we should add them up, right?
Whoa, slow your roll. We cannot simply add the forces. We are trying to find the force that the verb must pull, and we only have to add the x forces. Remember, you can never add x and y forces. I mean, it's like forces 101 at this point.
Right, jeez, so harsh, man.
Whatever. So,
The acceleration of the wagon is roughly 8.3 meters per second squared. We just estimated this value based off of Ferb's height. Now our equation for finding the force of friction is what we get from the coefficient of friction formula. As we all know, the coefficient of friction formula is equal to force of friction divided by the normal force. Now, we multiply the normal force on both sides, making it so the force of friction is equal to the coefficient of friction times the normal force. So now if we plug in 0.3 for the coefficient of friction and 6,468 for the normal force, we get 1,940.4 newtons, which is our force of friction. Now that we have the force of Ferb plus the force of friction, which is equal to the net force, which is also equal to mass times acceleration. All right, so this is a good place to be. We only have one unknown force. So force of Ferb plus 1,940.4 newtons equals to 660 times negative 8.3. Okay, so now if we solve everything, we will get 7,418.4 newtons. Negative 7,418.4 newtons.
Well, this is impossible because in order for Ferb to pull this indestructible wagon, plus the lion, plus the cage, he would be having to pull over 7,400 newtons in total, which is at least 3.12 times more than the average pulling force of a normal 10-year-old.
Great. So we got the answer we had already got 5 minutes earlier.
Anyways, what were we doing?
We were watching Phineas and Ferb, obviously.
That's right.